We will solve the following exercise. The exercise is the number 2.7. The vectors FA and FB represent the forces exerted on the pulley by the belt. Their magnitudes are FA equals 80 newtons and FB equals 60 newtons. Graphically determine the magnitude of the total force the belt exerts on the pulley. Okay, so what we have here is a belt, and that belt is applying a force using, in this case, these two vectors. That force is exerted on the pulley. So what I can do is to represent a resultant force from these two vectors for me to determine the magnitude of the total force exerted on the pulley. So what I have to do right here is to create the sum of these two vectors. In this case, what I have to get, or the answer that I require, is the summatory of FB plus FA. Okay, the way for me to do that is by, well, I'm going to draw again the two vectors right here. As you can see right here, this is FB and this is FA. This has an angle of 45 degrees with respect of the horizontal line, 45, and this has a measure of an angle of 10 degrees. Okay, with respect also to the horizontal line. Okay, so there is two ways in which I can solve this exercise. The first way is by moving this vector right here. The first thing that you have to take into account here is for when I want to create, or when you want to create a resultant vector, the tail must be touching the head of the tail of the first vector must be touching the head of the second vector. I could also have done this. Have done this. In this case, the result is going to be the same. Okay, so what I'm going to do, for example, is doing this. In this case, the resultant vector will be the summatory of these two, in this case this answer, and as you can see right here, the head of the resultant vector must be touching the vector that does not have that is not touching, okay, how can I say this, that its head is not touching anything. So this head is touching the tail of this vector, so I cannot use this head. So I gotta create a vector that touches these 2 points. In this case, the tail with the tail and the head with the head. Okay, I think that I've made myself understand that. So the answer will be, but will be this one. Okay, and the measure that we'll need is this one. Okay, so right here I have an angle of 10 degrees, an angle of 45 degrees, and these two I can assume that are the magnitudes of the two vectors. Okay, so FA equals 80 newtons and FB equals 60 newtons. Okay, as you can see right here, what I've created is a triangle in which I have to determine this length. Okay, so what I'm going to start doing is creating different triangle shapes. Okay, as you can see, I have a triangle right there. And how can I create another one? Well, I think that right here I have another triangle that I can use. Alrighty then. And then I'm going to need these lengths. Okay, as you can see right here, I have my first triangle. Okay, sorry, this line must be right here. Okay, so as you can see right here, I have my first triangle, my second triangle, and my last triangle. So for me to solve this, I'm going to create some different variables. Okay, so right here I'm going to say that this length, I'm going to call it x, for example. This length, I'm going to call it y. This length, I'm going to call it I don't know, h. And this length, red or orange, this one, I'm going to call it k, for example. So let me redo this, because I know that this could be a little bit confusing since I'm writing a lot of things on the same plane. So right here I have my first triangle, and right here I have my second triangle. Okay, this looks a little bit better. Right here. And I'm going to change the color of these two vectors. And as you can see right here, I have this length, which I've called x, and this length that I've called y. And right here I have this length with respect of this point, and that I've called it k, and this one I've called it h. Okay, so after I solve that, what I can do is to use this triangle, because as you can see right here, this is the vector that I require, right? So right here I have these two lengths, and this length is going to be y plus x, and this length is going to be h plus k. Okay, after I have these four magnitudes, what I should use is the Pythagoras theorem. That tells me that fa plus fb, the magnitude, plus fb is going to be equal to the square root of y plus x evaluated to the second power, plus, I'm going to write it right here, plus h plus k evaluated to the second power. Alright, so I need those two lengths. Alright, so I'm gonna start using the first triangle that I've created. This one. Right here I have the vector and these two magnitudes. In this case, k and y. This is equal to 60, and I have right here an angle of 45 degrees. I'm going to do the same thing with the second triangle. In this case, I have X and H and a magnitude of 80 degrees with an angle of 10 degrees. Of 80 newtons, I'm sorry, with an angle of 10 degrees. Alright, I'm gonna start using the angle that the problem gave to me. So in this case, I'm going to create, or I'm going to find these two magnitudes. Okay, so in this case, the sine of 45 is equal to k divided by 60. Remember that when you want to use sine, you have to use the opposite side of the triangle. Remember that right here I have an angle of 90 degrees. So I have to use the opposite side of this angle. In this case, k. Then k is equal to sine of 45 multiplied by 60. Right here I have my first answer. Okay, the second one, and I'm going to use cosine. The cosine of 45 is equal to y divided by 60. In this case, I'm using cosine because I need the adjacent value of the angle, in this case y. Okay, right here I have the opposite, actually in the opposite side of the triangle, and right here I have the adjacent, in this case in the adjacent part of the angle. So right here I have that y is equal to 60 multiplied by the cosine of 45. Okay, and I have my second answer. Then I'm going to do the same thing with the second triangle. So the sine of 10 is equal to h divided by 80. In this case, h is equal to sine of 10 multiplied by 80. The third answer that I need. And finally, I have right here that the cosine of 10 is equal to x divided by 80. So this means that x is equal to cosine of 10 multiplied by 80. Okay, for those of you who didn't understand what I just did, I used trigonometrical properties for me to find these four values. What I have to do right here, once I have the principal equation, is to pass the 60 multiplying the other part of the equation since it's divided. Okay, so right here I have the four answers that I require for me to solve the exercise, so I can replace those four in this equation, within this equation. So finally, fa plus fb is equal to the square root of y. Y is equal to 60 multiplied by the cosine of 45 plus x cosine of 10 multiplied by 80. It is evaluated to a second power. Let me move this around here because I'm out of space. And right here I have plus h is equal to the sine of 10 multiplied by 80 plus k. K is equal to sine of 45 multiplied by 60. This is evaluated to the second power, and the square root must be applied to the whole equation. Okay, so what I have to do now is to replace this on the calculator. So the square root of, open parenthesis, 60 multiplied by the cosine of 45 plus the cosine of 10 multiplied by 80, close parentheses, this evaluated to the second power, plus open parentheses, the sine of 10 multiplied by 80 plus the sine of 45 multiplied by 60, close parentheses, this evaluated to the second power, and that would be all. So the answer and the magnitude of FA plus FB is equal to 133.6557. I always use 4 significant digits after the comma. Newtons. Okay, why is that? Because we are talking about newtons right here. Right here. Okay. There is one way in which I can check that this result is correct, and this way is by using a software. I'm going to use CATIA in this case, so bear with me while I create the shape that we just did right here. Remember that you have some tutorials of this software within the channel, so if you want to learn how to use this software, you just have to look at them. Okay, those tutorials are pretty basic tutorials, but this is how you start to managing this kind of tools. Okay, right here I have these two vectors, and this vector will be the answer. Okay, this line. So I'm gonna start creating what I require with respect of this and with respect of this. Everything looks good. I think that this is not correct, so I'm going to create a line right here that has to be horizontal for you to analyze better this angle. Okay, this point is not touching this one. Okay, everything is defined since it's in green, so I'm gonna change the values that I need. In this case, this is equal to 10, this is equal to 45, this is equal to 60, and this is equal to 80. Okay, this is the shape, the correct shape. So what I have to do right here is to take this reference, and it is going to show me the answer. So right here you can see that it is equal to the 133.656 newtons. What you have to take into account here is that what the software is doing, this software CATIA V5 is approximating this value to the next one. Okay, since this 7 is above 5. Okay, so that would be all, guys. This is how this exercise could be solved.